that way.
It
Yeah,
opposes
it's that way.
the desired relative motion.
Okay.
So as I'm moving, so I start here and I accelerate, and as I'm accelerating, there's friction making this accelerate. I am not applying friction to the calculator. I do not have those powers. The only force you could possibly argue is I'm applying a gravitational force to the calculator, but that is so incredibly tiny, we ignore that until we get to chapter 7. If you start thinking that the gravitational force between any two objects, the generalized gravitational force, it is a path to madness. Because we'll be doing some complex force diagrams, and if you start bringing in those gravitational forces, you will basically double the amount of work you have to do. Just to give some sense, right now, the gravitational force between me and the Earth is somewhere in the order of just shy of 1,000 newtons. The gravitational force between me and the book is on the order of 10 to the minus 9th newtons.
How do you like convert your mass into a force?
You don't.
You know,
Because conversion has to be between two units that are of the same quantity. Now, I know what you meant, and so, but I answer what you actually said. So getting to more of what you were, I think, going for. How do you find your weight if you know your mass?
yeah.
That is a nice simple little formula. Weight is equal to mass times the acceleration due to gravity.
That's why I set it up.
So if I know my mass, I multiply times 9.798 meters per second squared to figure out what my weight is. Okay. Or sometimes we're on magical planets where the acceleration of gravity is just 10 meters per second squared, which makes the math a lot easier. Sometimes. All right, and despite what I was thinking, this class is not in at 350, but 320. So, have a wonderful afternoon. You think we do it at 320, right?
Oh, yeah. I don't know.
If Zachary hadn't packed up, I would have kept going.